Okay, hello everybody, and welcome to the webinar. This webinar is entitled Top 5 Time Wasters in Your Old CAD System. Now, using the word old CAD system, it might sound a little derisory, but really what we're referring to is any file-based CAD system. So whether you are coming from SolidWorks, Creo, Pro-E, Inventor, Solid Edge, NX, CATIA, essentially any 3D CAD system, or 2D even AutoCAD, based on files, is going to create a lot of time-wasting activities that really you could do without. So we'll take a look at what those are, and then also how they can be eliminated by using Onshape. My name is Neil Cook. My contact details are there, so you can see my email, my Twitter handle, and also my forum name. If you have any technical questions about Onshape at all, the forum is by far the best place to go. You will get a bunch of people falling over themselves to try and answer any questions, and a lot of employees, including myself, frequent there several times a day. So if it's any question relating to Onshape really can be posted in the forum after this webinar, and we'll get a response very quickly. During this webinar, you can ask questions. So you'll see on the GoToWebinar control panel, there is a question area. Just type in the question and it will appear to me. And then I will either stop during the presentation to answer those questions, or I will answer them at the end. I will stay behind for a few minutes at the end to answer any particular questions, or you can contact me using those contact details afterwards, and I will do my best to answer them. Okay, let's get started. So, top 5 time wasters in old CAD. I've picked 5 here. There are more. I think ones that try to pick ones which perhaps resonate with everybody. I'm going to use SolidWorks as many of the examples because that's the one I'm familiar with the most. But I have worked with every single one of those CAD systems that I mentioned earlier, so I do know that there's a lot of similarities. There are differences, obviously, but there's a lot of similarities in the way these programs work. And it's mainly due to, like I mentioned already, that they are installed on a desktop and they are based on files. And all the issues relating around those two things cause a lot of bottlenecks that are really unnecessary. Okay, so let's kick off and we'll jump into installation. Now, installation is one of those things that you only really can do once, or perhaps you only do it once a year, because many of those softwares that I've mentioned only come out at least once a year, certainly no more frequent than that. So an installation might sound like a one-time activity, and if you're a single user, it really isn't that much of an imposition. But you have to kind of put yourselves into the shoes of a CAD manager, CAD administrator, who might have a number of users to manage. And also, CAD isn't perfect. CAD is very complex software. So things go wrong. There are program errors, there are programming errors, there are bugs. So service packs are a very common thing in order to be installed and to upgrade and to do all the kind of things that you need to do to get your CAD system working the way you want it to. Okay, now this is again a little bit of a facetious graphic here, but it really is representative of a SolidWorks type install where the download is in excess of, that says just under 10 gigabyte. I think they're up to about 11 gigabytes now for a full download. So you're having to download it, it's having to extract it onto your hard drive. Then you have to install it, which involves putting all the license codes in, configuring all the different types of modules or applications that you've paid for. And then once it's installed, you then might need to go on to install any ancillary software. So, for example, if you're using some other application from that vendor, most typically a PDM system, then that's going to require extra effort to, again, download, install, license, and configure, which is probably the most important thing with PDM, is configure it for each user so they can access the data that they need to access. And the last thing I put in there is repeat, because as I mentioned, if you're a single user, it might not be such a big imposition, but if you've got multiple users, some installations can be 100 seats plus, then you're having to repeat all those processes one after the other. And it really is a real time suck. So as a simple example, some metrics from this, then taking SolidWorks, for example, they do 6 service packs a year. It takes approximately 40 minutes to download one of those service packs on a good internet connection. So anybody who's got a poor internet connection was going to take significantly longer. And if you've got a 5-user setup and it takes around about 22 minutes to install a basic SolidWorks install, then that alone is 15 hours per year of complete wasted time. Now that is, it's more than 2 days. Well, sorry, it's just about 2 days worth of work. If you split it up between multiple people, it might take less time. But again, because of this, a lot of these activities are done over the weekend. So there's no time penalties for a particular user during work hours, but they're paying overtime, etc., working on the weekend, trying to get everybody up to the right version of a piece of software so that all the files are compatible and there's no kind of issues with working on the same data. Things get compounded a little bit if you then have more of an extended enterprise, so you're working with customers or suppliers who also use the same software as you, or don't use the same software as you even. But even if they do use the same software, you have to make sure that they are on the same version and sometimes the same service pack to ensure that there is data compatibility between the two. So how do you do this in what we're going to refer to as Modern CAD? So in this case, Modern CAD is basically is Onshape, so it is entirely in the cloud. There is no files, everything is database driven. And provisioning a new user, if you think as well from an old CAD standpoint, what I've not mentioned there is procuring a workstation or a laptop which is good enough to actually run that software. So typically they would need large hard drives to store all the data and the actual program itself, and very powerful graphics cards in order to run that as well. So procuring those kinds of things, if you were to go to the Dell website, it's still going to take you, a week or so before that product is configured to your liking and shipped to you. So there's a lot of extra activities required. Now, Onshape, being entirely cloud-based, will work on pretty much anything. So it'll run on Macs, PCs, Linux, Chromebooks. Also has apps for iOS and Android as well, so you can run them on phones and tablets. But provisioning a new user is very simple, and let's just take a look at how you do that. So it is quite literally go to the users section and type in a person's email address. So you go something like put in their email address, specify whether they are a member or an admin. So an admin would then give you that capability to add more users and perhaps change some of the other company settings over here. Typically, a person will be a member. And then simply by pressing the add button, in fact, sorry, Corey's already got an account here. Let's do an example, somebody who doesn't have an account, and you can see it even better. So let's... So Katie, I know, doesn't have an account, so let's add her in. Now you can tell which people have an Onshape account already, or they don't, based on if there is an avatar or an email notification. And essentially, how that will look is, let me see if I can find it. So they will receive an email which looks something like this. So they're asking to add to a company or inviting you to join Onshape, and then go ahead and create your Onshape account. Now, if you've never used Onshape before, then it will ask you for a password, first name, last name, phone number, and sign up. And within moments, you will get into Onshape. You then have the full CAD capability. And if you've been shared some data, you get access to the data straight away. So there, for a start, is just the quickest way of provisioning a new user within your company, allowing them to get access to the CAD, access to the data, work together as a team. And the nice thing about this is that if that is perhaps a contractor you've invited in to work with you, you can get rid of them completely simply by pressing the X next to their name, and they will be removed. So any access to any of your data is gone. If you compare that to CAD that uses files, then once you've shared a file with somebody, you've no idea where that file's gone. Have they made a copy of it? Have they given it to somebody they shouldn't? Are they still working on it? there's lots of security and intellectual property concerns around sharing files with people outside your business. Okay, let's move on. So, talking about configuration here. So, I've talked briefly about configuring workstations with regards to about ordering them, configuring them. Is it a desktop workstation? Is it a laptop? It all depends on, and well, some people actually need both, depending on their activities. So it can be quite an expensive activity sourcing new CAD software. Now, obviously, when you configure a workstation, you've got to make sure it has all the latest drivers, all the latest software, antivirus, everything else on that. So again, that is a very time-intensive activity. Then PDM servers and clients. If you have PDM software, which if you're using files, it's very advisable because it's easier then to actually manage the data, see who has data, check things into the vault, make sure that people are not overwriting data or making changes to data that they shouldn't do. So setting up PDM servers and actually buying the servers as well to actually run it on in the first place, then going on every single machine and configuring the client again is it's a worthwhile exercise, but it does take a lot of unnecessary time. Standard content, if you're using nuts, bolts, screws, washers, anything like that, or standard parts, you would then have to work out how you're going to make that easily accessible by people within your business, and also make sure that there's a security there as well. So do you create shared network drives? And if people are remote, do they have to VPN in? Or do you put it into your PDM system? So there are many pitfalls and things to consider before you've even started. So again, these are kind of things that are not necessary when everything is stored in one central database in the cloud. And again, things like drawing templates and custom properties, likewise, things that you need to set up in advance, and also have some forethought about where you're going to store those and how they're going to be accessed by people who need it. Okay, with a modern CAD configuration, because everything is centrally located, there is no need to worry about where the data is or where it's going. So everything is stored in a database. So when somebody signs into Onshape, they get essentially the built-in data management is the first page they see. So they get access to all the data that they can only see the data that they have access to. So this is almost like the PDM system as well, if you like, but it's integral part of Onshape, and you cannot run Onshape without it. Again, people try to circumvent PDM systems because they tend to slow down your creativity with having to check things in and check things out and those kinds of activities. What makes it very transparent as well when you're working with a one single database is that you can get multiple people working on the same document as well, or working in the same project, working on the same data, and there's no worries about file copies, file overwrites, people making the wrong changes like you get with PDM and any kind of file-based CAD. Okay. Next up is crashes and data loss. Now, I'm sure nobody on this call has ever had their CAD system crash. Of course not. Then, it doesn't have to be just CAD. It can be any software crashes. It's just an inevitable thing. But CAD is particularly prone to crashes simply because of the complexity both of the software and also the unknown configuration of how the software will be used. And that can be seen in any number of ways. Is it the type of hardware it's being run on? Is it a certified hardware platform, or is it something that somebody's made out of bits and pieces? Also, how people use the software. Again, if you are a seasoned 3D modeler, you will know that to model even a block with a hole in, there's at least half a dozen ways you can do that. And making sure that all those permutations of how people use the software keeps it stable and not crash is very difficult to do. And that's really why CAD generally is quite flaky. And really, unless you're doing the most simplest of parts, then once you start doing something a little bit more complex, then crashes really kind of become inevitable and really kind of be a part of everyday CAD life. And people do kind of put up with it. There's obviously going to be a lot of screen punching incidents when a crash happens, but there is also a lot of other things that go on behind the scenes. Now, a simple crash during adding a fillet to a part is, it's not that much of a big deal. It does mean that you've lost any of the data since you last saved. But even if you have autosave on, the issue with that is that every time it autosaves, it's going to save over the previous autosave. So, if you're kind of working away and somebody's made a mistake or you deleted something, and then it autosaves and then it crashes, you've suddenly lost all those changes because you haven't got an undo anymore, and the autosave saved it after you deleted a bunch of things. So you have to be kind of a little bit more careful with that. And really, a lot of people tend to get this kind of Ctrl+S Twitch to save parts and assemblies often, because when crashes become an everyday part of life, then saving is an important thing you must do as well. And even a lot of CAD resellers will actually drum this point home, make sure that users do save often. But again, this kind of is a bit like the autosave as well. If you've saved something and then decide, well, actually, the previous what I was working on an hour ago was actually better than what I'm working on now, again, you've kind of lost that. Unless you've checked it into PDM or you've done a save as, then you've kind of lost that ability to get back to a previous version because you've saved, and perhaps you've closed it or opened it again and you've lost the facility to undo. But probably what you should be more worried about is if it crashes while it's saving. If it crashes while it's saving, there's a possibility that the file will become corrupt, in which case you'll not only lose the data since your last save, but you potential to lose the data in the file entirely. Now, it might just be a small part of a big assembly, but if you imagine if you've got to remodel that small part, it might take you, less than an hour to remodel the part. However, if that part is used in multiple different assemblies, then you'll have to edit each of those assemblies and change any references which are broken. If there was a drawing of it, you probably have to recreate the drawing because the one that exists refers to a different file. So there are many things which you should concern about when a crash happens. Obviously, sometimes it's convenient if you fancy going for a coffee, but crashes are bad. And just to give you a bit of an idea of why CAD crashes so much, is in any kind of architecture, especially the CAD architecture, there are some low-level components. So these are typically the modeling kernel, a sketch solver, graphics library. So if you're on SolidWorks, it's going to be Parasolid. If it's Creo, it's Granite. If it's CATIA, it's the CGM kernel, and so on. So some CAD systems use the same kernel. Some CAD systems use different kernels, but the fundamental architecture is the same. They will have a core geometry engine at the core of the software that's pinning up everything. Then at the second level, at level 2, they will have CAD specific code. So for example, SolidWorks and Solid Edge are based on Parasolid, but they both do things completely differently. So this will be the CAD specific code. So this is the CAD logic, how they do fillets, how they, create surfaces, how they put holes in. Each CAD software will have their own CAD specific code, which calls the lower level components and drives what the end result should be. And then right on top of that is the user experience, the user interface. So the icons, the graphics areas, the dialog boxes, the workflow of how you use that software. So this is really the basis of a typical CAD software. Now, another way to look at this is a house of cards. Again, a little bit facetious, but the idea here is that if something happens at the user interface level, only a few cards are going to drop, and that's easily recoverable. So developers are very easily able to create code which captures any errors at that level and recover gracefully. So it might be that your CAD system might come up with a dialog saying there's been an issue, your data is saved, restart the application, or it might even you might not even notice because the error reporting is clever enough not to disrupt the session. As you go a little bit lower, CAD-specific code might be sending wrong signals to the kernel, and then certainly if the kernel or any other components has an issue, then you're basically taking some cards out the bottom of this stack, and the whole house of cards is going to come falling down. And this is really why CAD crashes. Once one of the low-level components falls over, there is no way to recover gracefully from that. So then the errors go up the tree to then your crash dialog that I'm sure many people have seen when using CAD. Now, I want to contrast that to the way the Onshape architecture works in the cloud. Now, we use a lot of the many similar components that SolidWorks does, for example, in Solid Edge. So we use the Parasolid kernel for modeling. We use the D-Cube solver for our sketch, and plus multitude of other standard components, as well as our own CAD-specific code. So our own CAD-specific code will be in one of these servers. Now, I've drawn 3 here, but there are literally hundreds of them queued waiting to go. So when a user signs in through a web browser, it's going to pick up one of these servers. One of these servers will pick up an instance of a kernel, an instance of a solver, and an instance of every other element. Now, if one of these low-level components falls over, you can see there's a queue of these lining up ready to go. So if the kernel crashes, the Onshape server will just pick up the next available instance of Parasolid. And it doesn't even skip a beat. As a user, you won't even notice anything happens. And actually, when you speak to any of our Onshape users, they say Onshape never crashes. Now, it does in the background. A kernel will crash. It picks up another one. If one of these servers crashes for whatever reason, it'll simply pick up another one because the CAD data is in the same place, the CAD system is in the same place, and there's multiple instances of each element that can pick up if one fails. So if there is a crash, put a particularly complex fillet on a part and it causes the kernel to crash, you would never even notice. The worst thing that's going to happen is a message will come up saying, refresh your browser, and within 5-10 seconds, you're back to where you were. And one of the big differences as well is that because everything in the data is stored in the same place as the CAD system, all in a database, there is no save button. So when you do need to go backwards and forwards, you can get access to the data you need at any time. Okay, let me just go back up one and let's take a look at that. So if I was to look at a particular design, let's go for this one here, then you'll see that in Onshape there is no save button along the top here. So every time you do something, it is recorded and retained for the lifetime of this document. So you'll see there is in this document there is different lengths of cylinders, different assemblies. There's a bunch of different parts in here. You could also include drawings, although there isn't any in this particular one. But the interesting thing here is the amount of information which is in this document. So every time there's a modification to this, and it could be dragging an instance, okay, it could be renaming a tab. Anything that's done within here is recorded, and so you can see I did this back in March 10th last year. You can go back to any point in time and see what it looked like at that point in time. So in the scenario I mentioned earlier where autosave overwrites everything, that kind of thing doesn't happen in Onshape because everything is recorded and you can go backwards and forwards, giving yourself an unlimited undo redo for the lifetime of that document. Okay, the next thing I want to talk about is sharing and then collaboration, and I'm going to refer back to the dreaded CAD files. Okay, Now, whenever you're sharing data, and I'm sure everybody has experienced this at some point, and it doesn't really matter that much if you're sharing data with the person sat next to you, or they're down the hall, or they're in different location, different time zone. Whenever you're sharing data with an Old CAD system, you're creating and generating files. So each of these people has their own copy of their own CAD system installed locally on their machine, on their computer, usually Windows. So it could be the same CAD system. If it is, you have to make sure it's at the same version. If it's not the same CAD system, then you're going to have to work with neutral files, so things like STEP and DWG and things like this to be able to transfer data from one to another. Now, each of those people is generating files. Okay, we've already established that, and it doesn't really matter whether they're using PDM or not. If you want to transfer those to other people, then typical medium are FTP, email, USB stick, and all these are making copies of files. So here is the original file that was generated. Over here now is a copy. So once you start getting copies, then there's lots of issues relating to security of your intellectual property. Is it the right version? Has somebody manufactured to the wrong version? Okay, so it does happen. But also then, from the security standpoint, where are those files gone? Who has them? What are they doing with them? Are they doing things they shouldn't be doing with them, like making the wrong version? Or have they got the latest version? We really don't know. Now, there are ways around this, and people have tried to do this by having a file server, which might be something simple like a network share, or it could be something a little bit more sophisticated, like a PDM system. Now, a PDM system can be local, or it could be in the cloud. But essentially what you're getting here is once you start to share files with other people, either through FTP, email or USB, Dropbox, your PDM system, which might be in the cloud or not, or a file server, in order for that person to work on it, they have to make a copy. And this is just a limitation of files, particularly with Windows, is that when one application has a file open, then nobody else can have that file open in their own application. So even if you want two people to work on the same part or the same assembly, they need to have a copy. Now, obviously, once there are copies, then there's going to be conflicts. One person's made a change over here, another person's made a change over there. How do you merge those changes together? Or perhaps he's deleted something that you've worked all day on. There are lots of things that can go wrong when people are working on copies. Now, if we compare that with Onshape, then sharing data is very simple. Let's just use this particular document here. This is an imported file that's come from SolidWorks. So if we've got time, we'll take a look at how we work with this. But once we have a document, it could be an assembly, a part, drawing, or all combined. Sharing this with somebody else is very easy to do. So there are no files, so there's no way to export. I mean, you can, if that person needs to machine them, then perhaps you can export that. But again, we'll talk about some of the considerations when exporting data. But by far the easiest way to share data with somebody is to hit the share button in the top right. So you can, very much like Google Docs, you can basically invite somebody into your documents, and you can do that simply by adding in their email address and then specifying whether that person can edit or view, or you can transfer ownership if you wish. And so, for example, if you're wanted to share data with a supplier, and perhaps it's a new supplier you've never worked with before, you just want to request a quote, you might want to give them view and comments capabilities and include a personal message in there as well. Once you share that, they will get an email very similar to the one I showed earlier, which enables them to click on it and it will open it in Onshape. Now, particularly useful for suppliers is that you don't need an Onshape account. So if that person that you shared it with doesn't have an Onshape account, they can click the link and it will open the 3D model as we've seen in Onshape inside a browser. They don't actually need an Onshape account, which is great, because you don't have to get people to download, install anything. They don't have to learn how to use it. They'll basically get the simple manipulation tools, and be able to measure, and also because we give permission to comment, then you can get some kind of a dialogue going between yourself and the supplier when working out how best to manufacture a part. Now, if that particular person or company is a more trusted user, then you might wish to specify that as giving them edit capabilities, and then whether they can copy it, whether they can export it. They might need to export it into their CAM system. So give them export permissions and simply update that, and their permissions will then change. The user interface will change slightly. They can do more things like export. And then, very much like we created the user earlier on, and provisioned or deprovisioned a user, you can uninvite somebody from a document very easily, again, just by clicking the X, and doing that will boot them out of the document completely. Okay. Next, we'll talk about collaboration. I'm going to talk about it in conjunction with PDM, because really collaboration without PDM is what we just saw, which is file sharing. So you're sending something via a USB stick or email. With PDM, you're going to get a lot more control. You can invite users into your PDM system. You might need to buy some extra licenses to do that, but that's fine. Security is the most important thing. But to collaborate with them, you're still going to do a check-in and check-out process. Now, the issue, of course, with file-based CAD is that if you create an assembly like we see here, then it's going to store that assembly data within a file. And it's not just one file. It's essentially a file for every single part, assembly, and drawing which makes up that project. Now, once you start getting lots and lots of data, managing this thing in Windows Explorer and doing save as copies and renaming folders, it just becomes the stuff of nightmares. So really you have to kind of invest in a PDM system and a server and the software and the database, and then do these check-in activities. Now what's happening here is that the PDM system has now got a copy of the data you had on your laptop. So now there is 2 copies of the data. You would assume, well, you would know that that data is out of date because you're the one who checked it in. However, there's still copies lying out around on all kinds of PCs and desktop machines where people have used a PDM system and checked out data and made copies locally. Now, all that information is indexed in a database, which means that any future activity with anyone within your enterprise will actually be done directly with the database. That then checks files out, which is making a local copy to your local machine, and locks them. So what that means is then, once a file is locked, nobody else can work on it. They might have an old local copy on their machine, but now when they ask the PDM system for that data, they are unable to do anything with them. They can view it, but they can't edit it. So as far as collaboration, collaboration and PDM, you can't really put them in the same sentence. Okay, somebody's asked a question here. So when you share a document with a customer, model cannot be copied without giving them export rights. That's correct. By default, you can share a document with a customer. You can specify whether they can view or edit as the basic rights. And then when you get into the edits, you've got the option to enable them to copy it or give them export, or none of those rights. So you have a very granular control over who can do what. Okay, let's have a look at collaboration in Onshape. So we've looked at the share dialog already, and I'll just have to go through this again because I've deleted the user. So we'll add the email address, we'll give them edit permissions, no export, no copy, and go ahead and share that. Okay, what that means is that I can now, and if hopefully this will work, is try to get my. There we go. Okay, lovely. So this is my my iPhone. So of course, Onshape has applications for phones and tablets. And this is not just a viewer. This is the full CAD system that we can see on the screen here. Now, what you'll notice from a collaboration standpoint, and if I just shrink the screen down a bit, just pop this over here. Oops, no, I don't want to do that. I just want to move it. Thank you very much. Right, just so we can see both side by side. Then you'll see there is an icon in both telling me that there is somebody else within a document. So you can do things like, if you double click on the name, you can do what we call follow mode, so you can see exactly what one person is doing, which is ideal for collaboration. Okay, what you see this is the reason why this is slower here. This is the screen sharing thing here, because the model on my phone is actually moved to the same as this. So I apologize for that. That's not the best way to show it. Okay, but we shall persevere. Okay, let's turn follow mode off. Okay, and in fact, let's see if it makes any difference. Just give me 1 second. This will be worth doing if it speeds up. Let's try the screen sharing again. Yeah, there's a bit of I do apologize, there's a bit of a lag here. Okay, anyway, so you can have both people working on the same assembly, the same part, or anything within this document. So if we switch over to the actual part, you can even have multiple people working on the same part or even the same sketch. Now, we're working with imported geometry here, so this it just happens this was the document I had available. But if I wanted to do something like get rid of one of these notches, and let's just do a delete face on here, and we're going to say, okay, with all these things running and the GoToMeeting as well, if everything's grind to a halt here. Okay, let's take that, and we'll just do one. Okay. All right, there we go. So when I said that, in fact, you saw it there immediately. It's disappeared from the other part, and likewise. Okay, let's speed it up a bit now. You can do a similar sort of thing on here. So if you were to do, let's say, a move face, because you've got the full CAD capabilities here, you can pick a face and offset it, and then as soon as I press OK, it's going to update both the phone here and the CAD system as well. I apologize for the speed again. GoToMeeting's killing everything here. Okay, so that's just a quick look at how you can do like live collaboration, both doing in a design review mode using follow mode, so you can see what the other person's doing, and also you can have people working on the same part, the assembly, the same drawing, and also to the sketch level as well. So it's quite pertinent that when you get to the sketch level, having two people working on the same sketch is really quite crazy. So a question about there is your performance limitation internet speed at this point? No, it's not. It's something to do with this software that we're doing here. So suddenly you see everything speeded up. As soon as I killed that mirroring software for the phone, you can see that speeded up. And go to webinar doesn't really help either, because that is very power hungry. But with regards to internet speed, internet capability, I mean, I'm running on a well, it's about 60 megabit connection here at the moment. But the main important thing about running Onshape is really the latency, or the ping time. It's because the data that's transferred from the Amazon Web Services servers to your local machine is only very small packets of data. So the ping time, in other words, the responsiveness of the network, is more important than the actual bandwidth or the the speed of the connection as well. So latency is more important. Excuse me. You can run it on your phone with a 3G connection, and it's bearable. But once you get to like a 4G connection, it's absolutely fine. Anything above, sorry, excuse me. Anything above, certainly anything above 10 megabits a second bandwidth is certainly fine. Once you get lower than that, probably 2 megabits is probably the absolute minimum I would suggest running it at. But it doesn't take an awful lot of resources, and because you can run it on any machine, including like Chromebooks and Linux and so on, that you don't really need the high-powered machine or necessarily the high-powered internet connection to actually get it to work. Okay, and getting near the end now, I just want to mention here that that really overall that design is faster with Modern CAD. Now we've looked at some of the time-wasting activities or the non-value add activities of copying files, installing, configuring, sharing and collaboration. All these things are related to files, and if you can really take files out of the equation, then this is where you're suddenly getting a big speed up in your design process. So in the old CAD way of working, working with files and making lots of copies of files, you really kind of have to wait while one person finishes their work and checks that into the PDM so you can take it out and carry on with your work. During that time, obviously you can do other activities, but during that time you have no insight into what that person is doing. All you know is who's got it, who checked it out. They could have checked it out and gone on vacation. You have no idea. So you don't know what they're doing, if they're actively working on that, and if they are actively working on it, what are they doing? So it makes a very serial workflow. And really, it just takes more time. Now, if you contrast that with Onshape, in that everything is driven from one single database, there are no files and no copies. So you've just seen, although it's a bit slow because of the phone software there, there's no waiting. You can have multiple people working on the same data. There's no check-ins and check-outs, and that enables multiple people to work on the same data at the same time. And obviously that then, by its very nature, means that there is no waiting involved, and therefore you're going to compress the amount of time working. Okay. And really, it's all about letting engineers focus on doing their work, because there are some statistics banding about like 20% of time is spent with non-value adding activities, 30% of time is spent on IT issues, like setting up the computer, sharing files around, things that which don't add to the engineering process, things that just detract from it. So if you can spend less time doing those activities of working out how to collaborate with somebody by sharing files, then you can spend a lot more time doing what you're paid to do, and that's engineering. One of the other thing which I forgot to mention with collaboration is that if you are working with a third-party supplier and they perhaps machining some parts for you, they may have Mastercam, they may have Gibbs Cam or Esprit, or a multitude of different CAM systems that they may be using. You as a CAD person have no idea what's the best format for them to use. So when you are exporting data, assuming you have permission to do that, when you export data, you've got all these different types of formats that you can export, but you have no idea what format they want it in. So when you share it to somebody with export rights, they can do the exporting themselves. They might try Parasolid version 30 and then suddenly realize, well, actually, because Onshape's updated every 3 weeks, we are always on the latest version of Parasolid, whereas they might be, on version 27 or something, but they can mess around with that. It's not your concern whether they can read your files or not. You give them export rights, they can mess around with the settings to get the right format of part into their system. So again, it's another value add thing that you can remove from your area, your domain, and give it to somebody else to let them worry about it. So again, these are all types of activities which can make a big difference to your day. So in summary, Onshape with its secure cloud workspace really does compress the design cycle simply by the virtue of removing some of these real high value time wasting activities. So, you can get data from anywhere, you can share it with anybody, because Onshape, you deal directly with the vendor. There is no middleman, there's no resellers. You go directly to Onshape. There's no unsecured intellectual property because you're not sharing files. Everything is contained within Onshape, and you specify what that person can do with it. So if they're a trusted supplier, give them export permissions. If they're not, view only. There's no crashes or data loss ever. Yes, I mentioned before, yes, in the background it does crash, but you never notice it. And because every single action is recorded and you can go back to every single action as well, you never lose any data. And, there's no worry about not being able to undo, because you get a history entry for every single thing that you do with that document, and you can go backwards and forwards at any time. There's no files to lose or corrupt. Again, we've talked about that. No license keys. You basically have a sign-in, which is your email. There's no software to install. We saw just a moment ago that you can provision somebody just by typing in their email address, and within a minute or two, they can be up and running with 3D CAD, which is, unheard of before. And of course, there's no upgrades or version conflicts ever. We update the software every 3 weeks, but everybody in the world is always on the same version of Onshape at the same time. So there is no issues with versions, between version 2017 and 2018, for example. Everybody works on the same version, and therefore there is no conflicts. And that, at this point, is that. So I will stick around for a few minutes to answer any questions. But if you don't have any questions, I would like to thank you for your time. I hope this has been of value. Please get in contact with me if you need any particular questions, either with the email or through the forum. And again, thank you for your time, and have a nice day.